For question 1, Fatimah received an inheritance of 12,000 ringgit. She divided it into the 3 parts and invested them in money market fund, municipal bonds and mutual funds. And we are going to find out how much she invests in each of these options. The purpose of the study is to determine the total investment made by Fatimah in each type of fund and to solve the equation by using the Gauss-Jordan elimination method. Firstly, let's define our variables. Let X be the amount she invests in the money market fund, Y for municipal bonds, and Z for mutual funds. Next, we set up the equations. From the problem, we have 3 important pieces of information. Number 1, the total investment is Rm 12,000 ringgit. Second, she invests 4,000 ringgit more in mutual funds than in municipal bonds. Thirdly, after 1 year, the total interest earned was 670 ringgit. The next step is form the augmented matrix corresponding to the given system. After that, we applying Gauss-Jordan elimination method to change the matrix to a reduced raw echelon form (RRAF). Now, the matrix is in reduced raw echelon form. Convert this matrix to a corresponding linear system and then solve the system. The solution to this system is unique. That is, S is equal to 2,000, Y is equal to 3,000, and Z is equal to 7,000. The amount of investment made by Fatimah is as follows. By applying the Gauss-Jordan elimination method, we can find out the amount how much Fatimah invests in 3 different ways, which is money market fund, municipal bonds, and mutual funds. And the exact solution is found that Rm 2,000 ringgit was invested in the money market fund, Rm 3,000 ringgit in municipal bonds, and lastly 7,000 ringgit in mutual funds. In conclusion, this discussion highlights how Gauss-Jordan can effectively represent and solve complex financial allocation problems that involve multiple constraints.
So basically it talks about in the movie theater, it can be filled with 350 people and we need to find how many children, students and adults in the movie theater. So here we also have the price for child, student and adults, which is the different price. And we also have the information that the number of adults is half the number of students and the total ticket sales is 2415. And next we have the purpose of study, which is talk about what we want to find in this question and how we want to proceed in this question and what system of linear equations that we will be using in this question. Next we have methodology. So firstly, we need to substitute children, students and adults into unknown value where we use X, Y and Z. So here is what we will get. So next in step 2, we need to write the equation that we got from the text from the problem statement. So we have 3 equations that we got from the text. So next for step 3, we need to write the equation in step 2 into AX equals to B. So here is the matrix that we got from the equation 2 for step 3. So next we continue with step 4 where we will apply the Cramer's rule. And firstly we need to find the determinant of A where we use the covariant expansion method in order to find the determinant of A. So we get the value of determinant of A which is equal to negative 14. And next we need to find determinant of A1 by using covariant expression as well, but there's just slight difference in the number for the determinant of A1. So we solve for the determinant of A1 and we get the value which is equals to negative 2380. So next we still in step 4. So next what we want to do, we want to find the value of determinant of A2. Still the same way, still using covariant expansion, but just slight difference in places of number. So we got the value of determinant of A2 is equals to negative 1680. And next we need to find determinant of A3. Still the same way, and it still has the slight difference in number. So we got the value for determinant of A3 which is equals to negative 840. And here we have the results where we get the value of X, Y and Z For x, we get the value of x is equals to 170. For y, we have 120. And for z, we have 60. And we also know that children is equals to 170, and students equals to 120, and adults equals to 60. Next, we have a discussion kind of similar to results. We have the number of children is equal to 170 people. Students, we have 120 people, and adults, we have 60 people. So we also know that by using Cramer's rule, we can find the unknown value in matrix problem. So in conclusion, Cramer's rule has proven to be an effective method for solving system of linear equations. By translating the given conditions, we were able to find the exact number of children, students, and adults in the movie theater.
Next, we move to question number 3. Adelina sells 3 types of photos which has a different price. The given information state that she pays Rm300 to rent her booth, and her historical sales pattern give a relationship between quantities of small, medium, and large photos sold. We need to find out how many photos of each type of Adelina must sell to cover her 300 booth fee. The purpose of study is to determine how many small, medium, and large photos are needed to cover the booth rental cost. Second, to solve system of linear equations by using Gauss-Jordan elimination method. Firstly, we let x is equal to number of small photos, y is equal to number of medium photos, and z is equal to number of large photos. Next, we form the equation from the information given and write it in augmented matrix. Then, by applying Gauss-Jordan elimination method, we can find the value of x is equal to 9 small photos, y is equal to 6 medium photos, and z is equal to 3 large photos. And the result is as follows. By applying the Gauss-Jordan elimination method, the problem was successfully solved to find the exact number of photos Adelina needs to sell. The solution was 9 small photos, 6 medium photos, and 3 large photos. This case highlights how linear algebra is not just an abstract mathematical tool, but a practical method to solve real-world problems. In conclusion, this question demonstrates how the Gauss-Jordan elimination method provides a structured, step-by-step approach to solving real-world business problems modeled by linear system. By reducing the matrix to RREF, we determine the exact quantity of products, that is photos, that must be sold under specific constraint to meet a financial goal.
This question is about missing 3 acid solutions. Solution 1 10%, solution 2 40%, and solution 3 60% to make 100 liters of a new solution with a 45% acid. Each solution has a different acid strength. There is one special rule. The amount of 10% acid must be twice as much as the 40% acid because the 40% one is limited in supply. So our goal is to find out how many liters of each solution we need, so that first, the total volume is 100 liters. Second, the total acid content is 40% liters, and the amount of 10% solutions is twice the amount of 40% solution. The purpose is to represent how the chemist can combine the 3 different acid solutions to create a 100-liter mixture with a 45% acid content with specific constraints, and to apply the Gaussian elimination method in linear algebra to solve this equation. Move on to methodology. First, let x be the amount of 10% acid solutions, y be the amount of 40% acid solutions, and let z be the amount of 60% acid solutions. Based on the given conditions, create the system of equations and create the augmented matrix. First, solve until the matrix is in the row echelon forms REF. Next, convert this matrix to a corresponding system of linear equation as shown. Then lastly, solve the system by using the back substitutions. Since we already knew the value of z, just subs in the value into the first and second equations to find the value x and y. Then we got the x equals to 25 and y equals to 25/2. By using the Gaussian elimination method, we found the exact amount of each acid solution needed for solution S equals to 25 liters, second solution Y equals to 12.5 liters, and third solution Z equals to 62.5 liters. This method helps us to calculate the right amount of each solution to get the desired mixture. To conclude this case, the Gaussian elimination method is a clear and organized way to solve a real-life problems like this. By turning the volume, acid concentrations, and the ratio into a system of equations, we were able to find the exact amount of each acid solution needed for the mixture.